Introducing a breakthrough in quantum computing, the Majorana 1.
NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
The Voyager 1 spacecraft is sending back updates on its science and engineering data after spending 5 months in silence.
For months, it was as if Voyager 1, the farthest human-made object in existence, had fallen into a deep, unintelligible silence. Orbiting a mind-bending 14 billion miles from Earth, the spacecraft had been sending home data that made no sense. Just static, just noise. Until now. Against all odds, that silence has been broken. Launched way back in 1977, with tech that's now outpowered by even basic home appliances.
But launched in 1977, Voyager 1 was mankind's first spacecraft to enter the interstellar medium in 2012.
Voyager 1 is once again transmitting data that scientists can actually make sense of. As of early 2025, it's drifted more than 167 astronomical units away, so far that a single message takes over 22 hours to reach us, traveling at the speed of light. But it's what's in the data that has some experts paying very close attention. Hidden inside what appears to be routine system updates are strange patterns, very specific patterns. Think prime numbers, repetitions of constants like pi, even a mysterious spiral-like structure buried in the signal's framework. These aren't your typical glitches. And here's where it gets even more interesting. A new breed of quantum computer, the Majorana 1, just revealed by Microsoft, was used to analyze these signals.
Microsoft has made a giant leap in quantum computing with the development of the Majorana 1, the world's first quantum chip.
Thanks to its cutting-edge quantum core, it reportedly uncovered relationships too precise, too structured, to be dismissed as coincidence. Some specialists are calling this the most mathematically coherent anomaly ever detected from deep space.
Voyager 1 is still beaming back data. The mission team is scratching their hands at what looks like an issue with the spacecraft's system data.
So what's really going on here? Is this just a bizarre artifact of aging tech? Or has something fundamentally changed in Voyager's journey through the stars? You're still here because you're not one to accept surface-level answers. You're tuned in because you're curious about what lies beneath the noise. To begin answering that, we need to rewind, back to when it all started. The journey of Voyager begins. September 5th, 1977. The day a 722-kilogram craft left Earth for what would become the longest voyage in human history.
Voyager 1 lifted off on September the 5th, 1977, 16 days after its slower twin Voyager 2.
Voyager 1 was never supposed to make it this far. Originally built for a short 5-year tour of Jupiter and Saturn, the spacecraft wasn't designed for longevity, and yet, here we are, nearly half a century later, still in touch with this tiny, persistent machine, drifting at the edge of everything we know. As of February 2025, Voyager 1 is more than 15.6 billion miles away from Earth. That's about 167 astronomical units, a distance so vast it's hard to grasp. To put it another way, if you sent a light-speed message to Voyager right now, it wouldn't answer back for almost a full day. Since 2012, it's been sailing through interstellar space, having crossed the invisible boundary known as the heliopause, where our sun's influence finally fades.
The solar system has a magnetic bubble around it called the heliosphere. Voyager 1 is now in the heliocliffe, or the edge of the heliosphere.
And somehow through all that, it's still whispering back to us, using just 23 watts of power, the same as a basic light bulb. Voyager 1 transmits through NASA's Deep Space Network at frequencies of 2.3 and 8.4 gigahertz. By the time its signals reach Earth, they're so faint they carry less energy than a single bacterium uses to swim. And yet we hear them. Running on a 68 kilobyte computer, yes, kilobyte, not megabyte or gigabyte, Voyager's resilience is borderline miraculous. It still draws power from a small plutonium generator that could keep one science instrument alive well into the 2030s. But let's be clear, the journey hasn't been smooth. In 2022, Voyager started sending corrupted data after
Something weird is going on with Voyager 1's AACS controls. Well, the antenna appears to still be functioning properly, but the telemetry data that the team is getting back from the spacecraft is wrong.
an onboard system began routing information through a dead computer. Engineers remarkably fixed it. Then in late 2023, another glitch hit, corrupting the probe's memory and halting scientific transmissions altogether. That issue, too, was resolved by April 2024. And it's within this turbulent context that the latest mystery has emerged. Skeptics argue that these patterns found in the new transmissions are just another glitch, more digital noise like Voyager's had before, just more static from an aging machine. But supporters of the anomaly theory say this time feels different. Here's why. The level of mathematical order reportedly embedded in the data goes far beyond what previous malfunctions have ever produced. And the biggest twist? Those patterns weren't uncovered using traditional analysis. They were reportedly spotted using quantum computing. In February 2025, Microsoft unveiled a machine that changed the landscape, the Majorana 1, a quantum processor named after Italian physicist Ettore Majorana. It's not just a leap forward, it's a whole new framework. Built on a topological core, the processor uses ultra-stable qubits called topoctors.
Microsoft has introduced Majorana 1, the world's first quantum chip powered by a new topological core architecture,
enabling it to run calculations that classical machines simply can't. The current model supports 8 qubits, with the potential to scale into the millions. Now here's where things get intriguing. Shortly after the Majorana 1 was announced, researchers using the system claimed to detect a level of precision and structure in Voyager's signals that had never been seen before. Coincidence? Maybe. Or maybe the patterns were always there, just waiting for us to develop the right lens. What exactly did they find? For starters, sequences of the first 10 prime numbers, 2, 3, 5, 7, 11, and so on, nested within seemingly random signal fluctuations. That alone is odd, but even more bizarre were reports of fundamental constants, like Planck's constant, and the fine structure constant, embedded within the data, each appearing with a micro variation of precisely 0.013%. Tiny, yes, but deliberate? Could a 48-year-old probe really produce this kind of order on its own? Or are we glimpsing something far stranger, hiding in plain sight? What if a signal from deep space doesn't just carry information, but architecture? That's the unsettling possibility raised by researchers analyzing Voyager 1's most recent data. When passed through next-gen quantum algorithms, the transmission didn't just sound different, it looked different. The raw signal, once converted into spatial data, allegedly revealed a spiral geometry with unmistakable patterns. Patterns that mirror the Fibonacci sequence and proportions tied to the golden ratio. These are the same blueprints found in everything from seashells to galaxies. Natural, yes, but not something expected in a fading broadcast from a spacecraft nearly 5 decades old. And then there's the number 127. Here's where things take a stranger turn. Independent quantum labs running different systems have reportedly produced the same results. Identical structures, repeating constants, and now, a digital-like framework hiding in the noise. Some claim that during a brief 72-hour window when Earth went silent, sending no signals to Voyager, the patterns began to break down. But once contact resumed, they reappeared. Sharper hat's not how random interference behaves. The skeptics versus the unsettled. Naturally, not everyone's convinced. Critics argue this is just quantum computers doing what they sometimes do best, finding patterns where there aren't any. According to that view, Voyager's latest transmission quirks are no different than past problems, like the 2022 incident where it misrouted telemetry, or the memory corruption issue from late 2023.
We meet the NASA scientists who repaired a spacecraft from 15 billion miles away, the Voyager 1.
Seemed mysterious at first. Both turned out to be technical faults, nothing more. And in NASA's eyes, everything's normal. No anomalies confirmed, No public acknowledgement of anything out of the ordinary. The spacecraft is healthy. All 4 instruments are active. Signals are stable. That's the official version, but unofficially, theories continue to ripple. One possibility gaining traction among the more speculative circles is this: Voyager wasn't just malfunctioning, it was modified. Imagine something intercepting the probe's weak 23-watt signal, rewriting the data midstream and sending it back toward Earth. Sounds like science fiction, but if you believe the claims about entanglement-like properties showing up in the signal, it raises questions. This kind of data complexity shouldn't even be possible with the energy Voyager outputs, unless something is boosting it remotely. Here's where comparisons emerge with quantum experiments like China's Messias satellite, which demonstrated secure communications using quantum entanglement. Could something, somewhere, be applying similar principles, but on a cosmic scale? If that's true, it changes everything. This isn't just a malfunction, it's a message, and the messenger? Our own probe. Then there's another theory, more grounded but no less fascinating. What if this signal is coming from Voyager, but not by accident? Some believe that when NASA patched Voyager's failing memory in 2024, it may have unknowingly activated dormant code, a function buried deep in its original programming, never intended to be used. Perhaps it's something left behind, a contingency for a scenario no one anticipated, or perhaps something Voyager picked up, absorbed and adapted. Critics are quick to dismiss this. They point out the spacecraft's specs. 68 kilobits of memory, no rewritable storage, no room for surprises, and yet, if decades of space exposure somehow unlocked hidden behaviors, would it really be that implausible? These are the edges where certainty ends, and exploration begins. A signal or a shadow of the past? Some experts argue that a machine with just 68 kilobytes of memory, running on bare-bones assembly code, shouldn't even come close to outputting structured mathematics. And yet, that's what some say Voyager is doing. Skeptics are quick to dismiss it. Too old, too simple, too broken. But there's a counterpoint whispered by those who've spent a lifetime studying space tech. Maybe it wasn't just a science mission. Voyager launched in 1977 in the middle of a Cold War space race.
The idea of outer space becoming a battlefield is a terrifying prospect. The UN's 1976 Outer Space Treaty upholds a ban on nuclear weapons in space.
An era when what we saw and what was actually there weren't always the same. Proponents of this theory suggest Voyager may have carried dormant systems, hidden functionalities designed to awaken under very specific conditions. Not a glitch, not a message, but a trigger. And that trigger? Reaching the threshold of interstellar space. If true, it would raise a deeper question. What was Voyager's mission really about? But not all theories point to intentional design or intelligent origin. Another possibility, perhaps just as stunning, is that Voyager is drifting through a region of space unlike any we've studied before. What if this isn't about the spacecraft at all? Some researchers suggest that interstellar space itself, its complex weave of magnetic fields, cosmic rays, dust, and dark particles, could be interfering with or even modulating the signal. That would mean Voyager's transmission isn't being changed by an outside intelligence, but by natural structures embedded in the space it travels through. If this idea holds weight, it could point to new unexplored physics, an environment that affects radio signals in unexpectedly mathematical ways. Not a message, but a mirror reflecting strange properties we've never encountered. Voyager may be more than a messenger. It might be the first instrument to detect nature's own encryption. If it's real, what happens next? So, what would it take for this to be taken seriously? In a word, evidence. The SETI, Search for Extraterrestrial Intelligence community,
the search for alien life just took a giant leap. Scientists may have found the best hint yet.
Has well-established protocols. No theory, no matter how compelling, gets recognition without multiple, independent verifications. Signals must be replicated, peer-reviewed, and confirmed across different instruments and teams. As of now, mainstream SETI efforts continue focusing on optical and radio telescopes, like the Allen Telescope Array, hoping to detect unmistakable technosignatures from the stars. So far, nothing conclusive. But if Voyager's signal contains even the faintest trace of intelligent design, the approach to signal detection could be due for a radical transformation. That's where quantum computing may change everything. With hardware like Microsoft's Majorana 1, the search isn't just about listening harder, it's about thinking differently. Quantum processors can see through the static, revealing structures invisible to classical systems. It's not about just collecting more data, it's about understanding it in dimensions we've never computed before. And if the structured data from Voyager is real, then this won't remain just a scientific curiosity. It will become a matter of national and global security. Governments around the world have contingency plans for what to do in the event of a verifiable signal from beyond Earth. These protocols are no longer theoretical, they're detailed, rehearsed, and ready. They involve information control, international communication channels, and rapid response teams to analyze implications. And if Voyager's signal has been altered, intentionally or not, every major intelligence agency on Earth would want to know. What changed it? Who's capable of doing that? And what else could they access? Suddenly, deep space communication isn't just about science, it's about defense. Even without confirmation, even as this sits in speculation, one thing is already happening. Minds are shifting because the real question isn't whether Voyager's signal was changed, it's how we're choosing to interpret it. Across history, whenever humanity encountered something truly foreign, it was never just the discovery that mattered, it was what it made us see in ourselves. If mathematical patterns from the edge of interstellar space turn out to be real, if they're not random, not noise, not a ghost in the machine, it would demand we rethink what it means to be alone.
It appears we are not alone in the universe. Scientists have identified the strongest signs yet of life beyond our planet.
Religions, philosophies, sciences, all would need new language. Borders might seem smaller, our sense of importance might bend under the weight of a larger story, and Be the Eskimos is finally whispering back, and maybe we've just started to notice. The people drawn to these questions, the ones staying with you through each twist of signal theory and each breakthrough in quantum analysis, aren't just curious. They're preparing not in fear, but in clarity, for the possibility that reality is bigger, more layered, more responsive than we've been taught to expect, for truths that won't arrive in headlines or official memos but in subtle signals, mathematical whispers, and moments of stillness that say, "You're not imagining this. Keep going." Your willingness to explore these ideas means you're not just a consumer of information, you're part of a cognitive frontier, a group attuned to early signals of transformation, unafraid to ask the questions others call premature, fringe, or impossible. Even if the reported anomalies fade into the category of unexplained but natural, Voyager 1 remains one of the most extraordinary human artifacts ever created, launched with a 5-year mission, now past its 48th birthday, still speaking, however faintly, across a gulf of 15.6 billion miles. It carries not just instruments, but a message. A golden record filled with our languages, our songs, our hopes.
Almost 4 decades later, that craft is over 12 billion miles from home. Voyager carries a golden record containing a greeting from the people of Earth.
Music from Senegal, greetings in Navajo, a kiss from a mother to a child. An invitation across light years to anyone or anything, listening. As Carl Sagan said, the launching of this bottle into the cosmic ocean says something very hopeful about life on this planet. Voyager is a love letter written in physics and copper, sealed in time, drifting outward. And even when it falls silent in the 2030s, it will keep going. It will outlive us, Earth, maybe even our sun. It will be the last whisper of our civilization moving through space, a trace that we tried to matter. Whether or not the recent signal patterns are real, whether or not quantum processors like Majorana 1 have glimpsed something hidden, it doesn't change the fact that we are, for the first time, beginning to look differently. This isn't just about aliens. It's about how we interpret complexity, how we assign meaning to patterns, and how we remain open to new modes of recognition. It's about a deeper understanding of our tools, our models, our very definition of intelligence, human or not. We've barely scratched the surface of what the universe is, what it contains, and how we might listen. The quest doesn't require confirmation to be worthwhile. It's in the attempt to understand, the effort to reach, the refusal to dismiss what doesn't fit. In a universe that remains silent most of the time, we are the anomaly, curious, reaching, building golden records and sending them across the dark. And so even if Voyager's signal holds no secret code, even if it's just fading electrons from an aging machine, the fact that we're still listening, with better tools and bolder minds, says something profound. It means we're still awake, still willing to notice the signal before others do, still asking the questions that mark the beginning of something larger. You've already shown you're not just a passive observer. You're one of the few who made it this far, willing to think past the noise. So, stay with this. The next signals might not be from Voyager, but they'll come from somewhere, and you'll recognize them because you've already learned how to listen.